Okay, so this is a project I started working on basically yesterday. So let me kind of explain what's going on here. Basically, if you've ever played the game Pop, the idea, of course, is it's a physics-based game where you are controlling this guy who's sprinting along a track, right? And so I've seen various people online, basically, a couple people before have, used reinforcement learning to train the quap guy to run, right? And so what I was interested in doing is basically exploring the design space of basically what games will be in the future once they have um, once characters rather than being um, driven purely based on animation state graphs. They use more advanced technology like basically robot reinforcement learning policy rigs. And right now, characters in games primarily use um, the animation graphs and combined with inverse kinematics for legs and arms, and sort of combinations of those things if you look at like Unreal Engine control rig, right? So that's really kind of cool, but the future beyond control rig, beyond kind of that synthesis of inverse kinematics and animation state graphs is moving towards basically just accurate physical policy. And there are some things that like basically can happen in these sorts of states that that can't really happen in existing video games. And a good example is that basically like if your character trips or if your character is hurt or something like that. And to me, it really seemed to like, you sort of see some of this work emerging on robots for locomotion policy. And to me, what's really interesting is the possibility of generalizing this, basically taking what has been created for robotics and then bringing it back to video games. And a lot of physics-based video games are sort of, how I'd phrase it is they are like physics as a gimmick, or like kind of like, getting over it, or Fall Guys, right? They sort of treat um, the kind of physics as sort of a joke or something, kind of some element of fun. But the idea here is to take this idea of a physically based character in a different direction, which is different from inverse kinematics and an animation state graph, which would be how I roughly phrase what this is something like a reinforcement learning neural policy graph combined with eventually um, like essentially entity relational artificial intelligence systems. So basically, some of my ideas are like, imagine if you had basically a few of these robots and their large language models. And so basically, also you can see here I have kind of this example of my idea, which is that you can sort of like simulate various neural policies into the future and project where the character will be. And even though it seems kind of basic right now, this sort of thing makes a lot of sense, like from a game perspective, once you're using it to train say a graph of neural networks. So and basically once there is sort of other agents involved. Um, so this is just what I've been able to kind of with Claude to kind of get working in a day. You can see to get an accurate walking policy, and it's not the best at all. Um, I have various reward constraints over here on the bottom left. Like basically, the reward is not just increasing the x distance, but maintaining a bunch of different constraints. You can see that if I go to a different policy, like that PBR Live policy, then yeah, you can see that it learns to walk in kind of it kind of learns a degenerate strategy here in PVO condition, where it's not super accurate. And you can see that um, these policies fail. These policies fail in a non-uniform terrain. So you can see, basically, there's what's really fascinating from this perspective of game design is once we move away from a static animation graph to real physics-based character animation, then there are various types of generalization um, which need to kind of occur within the, such as generalizing to, in this case because it's a robot-based game, generalizing to different bodies or different things which are being carried from a physical perspective, as well as generalizing to different terrain, as well as generalizing the reinforcement learning policy to different at runtime constraints, like keeping the head up or keeping the head level or um, reducing power consumption as a gameplay element. So this is just me recording a video about this project, and I'm basically really the reason why I kind of sort of more or less had to um, see what was possible here is because um, I just have been really wanting to play a reinforcement learning robot based video game, and no one's really making it. Um, so this is sort of my short term attempt to do that.